Hi, this is Mrs. Angela T, and this video is for H1 Chemistry on the topic redox reactions. In this video, you will learn how to write balance equations for redox reactions. Oxidation and reduction always takes place together in electron transfer reactions. Writing equations for redox reactions can be easily done with the aid of the data booklet. So do have your data booklet with you. Now, the reason why we want to write equations for redox reactions is because we want to know the stoichiometric ratio of the reactants, and some of these stoichiometric ratios are not so easily determined like your acid-base reactions. So in the data booklet, a list of half equations is given. Half equations are essentially equations that have electrons present in them. So let me show you a sample of the data booklet. So your data booklet has a list of half equations and they look something like this. So things to take note. If you notice, the electrons are represented here with the E minus sign. So in the first one, this is 2 electrons or 2 moles, 2 moles, 2 moles, 3 moles, 1 mole, and so on. And also all the half equations in the data booklet are presented as reduction half equations. This is just to standardize the presentation format. Reduction means gain in electrons. If you remember from a previous lesson, the acronym OIL-RIG. Oxidation is the loss of electrons, reduction is the gain of electrons. So you notice all the equations here are represented as reduction half equations. All show a gain in electrons. Now let's just look at one particular equation here. Let's take a look at this reduction half equation. Just give me a minute to erase these. Now, if you look at this reduction half equation, you can see that iron 3 plus gains electrons to form iron 2 plus. This is a reduction half equation. If the data booklet gives all the half equations as reduction, how do we obtain the oxidation half equation? Through logical deduction, if you want the oxidation half equation, you should read the equation from right to left, because from right to left shows iron 2 plus being oxidized to iron 3 plus. So you just need to so-called flip the equation around. So in the reduction half equation, iron 3 plus is the reagent, iron 2 plus is the product. But in an oxidation half equation, iron 2 plus is the reagent and iron 3 plus is the product. So let's move on to the example of how to write balance equations for redox reaction. You're asked to write a balance equation for the reaction between potassium manganate 7 or KMnO4 and iron 2 sulfate in an acidic medium. Most of the mediums that we encounter here are acidic. Okay, I will elaborate later. So in your notes, step 1, identify the substance undergoing reduction and the substance undergoing oxidation. So do note that KMnO4 is your oxidizing agent. So it's the one that will undergo reduction. And that makes your iron 2 plus that will undergo oxidation. I want you all to take note that potassium plus and iron 2 and the sulfate anion, these are spectator ions. They do not take part in the chemical reaction. The reasons for that is beyond the H1 scope, so it's best that you know for a fact that K plus and SO4 2 minus do not undergo oxidation or reduction. In step 2, write the half equation for the reduction process and the half equation for the oxidation process. So now you need to refer to your data booklet. It's always easier to write the reduction process first, since your data booklet gives all your half equations as reduction half equations. So now you need to look at your data booklet, and this is the top of the data booklet. Notice everything is presented in alphabetical order. So your KMnO4, essentially your MnO4 minus, this is the anion that's being reduced. So you look at it alphabetically to look for the MnO4 minus. So if I were to move further down the data booklet to this part, you will see that your MnO4 are over here. In fact, there are 3 equations that contain MnO4 as your oxidizing agent. So the question is, which one do you choose? Now this is what you need to know, very important. The only equation that's in your syllabus is this one, the one that has 8H+. Remember earlier I said that your redox reaction occur in acidified environment. This acid refers to your sulfuric acid. This is the most common and probably essentially the only acid that you can use to acidify your KMnO4, because most other acids will react with your KMnO4. You just need an acidic medium. You do not need the acid to react with your KMnO4. So it's the sulfuric acid that is contributing to the 8H+. These other two half equations you do not need to use in your syllabus. So please take note of which half equation to use in your exam. So this is for the reduction half equation. This is the one to choose. Now what about the oxidation half? You need to look for iron 2. If you look at your data booklet in alphabetical order, iron 2 is present here, and iron 2 is also present here. Which half equation do you choose? This half equation shows iron 2 being reduced. This half equation shows iron 2, you read it backwards, being oxidized. Now, if your reaction already has something that's being reduced, your oxidizing agent, which itself is being reduced, MnO4 is being reduced, obviously it needs to react with something that will be oxidized. So this is the half equation that you should choose. So I need to flip this around. So the other half equation is iron 2 to give iron 3 plus electron. Now another thing I want you to take note, let me clean this off, is once I write the half equations, the arrow I use is a single direction, because this is the oxidation process I'm talking about, and over here at the bottom for my MnO4, this is the reduction process I'm talking about. The arrow should be single direction. You should not copy the double direction arrows in your answers, because once you've determined the direction of the reaction, that is the way it's supposed to go. So now I have my oxidation half and my reduction half. So let me show it to you in another slide. There you go. The reduction half taken from data booklet and oxidation half taken from data booklet flipped over. So what I need to do now is to combine these two equations, two half equations, to give the overall reaction. So if you look at step 3 in your notes, multiply each half equation by an integer so that the gain of electrons by reduction is equal to the loss of electrons by oxidation. So the gain of electrons here is 5 moles. The loss of electrons is 1 mole. It's not balanced. So what I need to do is to make the electron numbers balanced by multiplying the iron equation, the iron half equation, by 5. 5. That's the lowest common multiple. Okay, just let me highlight the arrows. Oops. Pardon me. Okay, let me just highlight the arrows here so you can see where the arrows are. Yeah. Okay, so now notice, right, that reduction half gains 5 electrons. The oxidation, 5 moles, will lose 5 electrons. So all I need to do is to make sure that the number of electrons cancel out. So this cancels with this, and anything on the left side of the equation, these are my reactants, and anything on the right side of the equation, these are my products. So if I were to write it out nicely, MnO4 minus and 8H plus with 5Fe2 plus to give me, single arrow, Mn2 plus and 4H2O and 5Fe3 plus. There you have it. That's the overall equation. Very messy handwriting. Let's look at the proper one. Okay, so this is the overall equation. Now what's important about this equation? This is the stoichiometric ratio you're interested in. MnO4 minus stoichiometrically equivalent to 5 moles of Fe2 plus. So this is the mole ratio that you'll be using in your calculations, like your titration calculations. This 8H plus is just to tell you that there is an acidic medium provided. Because if the medium is not acidic, you will get a different set of products. You may not get these products. Okay, but that's beyond your scope. So the important thing to take note of are the half equations required in your H1 chemistry syllabus. They are the potassium manganate 7 equation, which is the one I mentioned earlier. Another oxidizing agent you need to know is your potassium dichromate 6. This is present in the data booklet. You do not need to memorize this by heart. You just need to know where to find it in the data booklet. And iron 2 to iron 3, which is your oxidation half that is found as a reduction equation in your data booklet. So with this knowledge now, please try your work examples.